All right. So my project is about how splitter plates can affect the vortex shedding and vortex or fluid structure interactions on hydrofoils. So pretty much the same as Hassan earlier, but only with splitter plates instead of vortex generators. So yeah, the background of the project is to investigate how or when they use hydrofoils in hydropower plants, as the shedding frequency is approaching the natural frequency of the hydrofoil, you will get resonance, and that will cause fatigue on the material, and you'll have to change the guide vanes and stuff more often. So you would like to avoid that. And the idea is to use a splitter plate, which yeah, it's pretty hard to see on this one, but it's a small plate at trailing edge on the hydrofoil there, which will, the idea is that this plate should break up the vortex shedding, so it reduces the amplitude of the shedding and hence reduce the vibrations caused by the vortex shedding. And these kind of splitter plates have shown good results on cylinders, where they are reducing the vortex shedding and the vibrations, and also reducing drag forces caused by the vortex shedding. So yeah, we'll see how they work on a hydrofoil. The design I'm going to use, I have the, if you see A here, it's the foil body, and then B is a trailing edge tip that can be glued to the foil body, and then I made planning to make a small slit in the trailing edge tip, where I can glue a small plate in, which will be the splitter plate, and this will make it easier for me to change between different lengths of splitter plates, so I can test how different split plate lengths affect the shedding frequency and vibrations. Yes, I will also investigate how, for example, a splitter plate in rubber could work, because that is interesting when talking about the guide vanes in hydropower plants, since they're supposed to close off the water stream, or they should be able to. So if the split plate is stiff, they could maybe make it hard to close off the water stream. So if it's able to bend, for example with rubber, it would be more convenient when using in hydropower. Yeah, and the manufacturing process will probably be to mill out the slit from the trailing edge tip, which are produced by another company, and then the split plate will be glued in place when doing the experiments. Yeah, so the measurement activities that is going to be used are PIV, where you can see the test rig here. Yes, not so much to say about that, but it's a laser sheet that's coming from above, and then you have a camera that is perpendicular to the laser sheet. And you have also attached on the hydrofoil, there's supposed to be strain gauges that are measuring the vibrations in the hydrofoil. There are also possibilities to do CFD on this, but we'll see when I get time, or how much time I have. So that's most of it.